Right, welcome back to summary class auto for the indices. Perhaps you have not watched the summary class for O1. We have done it before, so go and do it now. Go and watch it, and don't forget to like, subscribe, and share. In the O1, we talk about the indices, what is it like, and we talk about the laws. Now we are moving from there, the continuation of the laws. Now, as you can see, law 6 says that if you have a raised to power m times b raised to power m, don't forget that I told you in the last class, I said a and b, they are just like variables, and m, they could be anything, so don't get yourself confused. So this will result to a times b raised to power m. For example, we have 5 raised to power 2 times 6 raised to power 2. This will give us what? You multiply the number 5 times 6 raised to power 2. So this will give us what? 5 times 6, that's 30 raised to power 2. And you know 30 raised to power 2, it means that we have 30 in 2 places. Like 30 times 30. So now for this one too, and I want you to take note of this thing. Anytime you are dealing with indices, know that all those laws, they are reversible. They said it is equal, that means it is reversible. The left hand side is equal to the right hand side, so it can be reversed. They can give a question, can come in the reverse form of indices law, or it can come in the way it was given. So take note of that. So 5x raised to power 3, this means what? This theory is meant for everything that we have inside brackets. You know, 5 and x, they are entirely different. They are different things. So this is variable, this is number. So like we have something like this. This will split is the same as what? 5 raised to power 3 times s raised to power 3. That's what you have. So this is the reverse form of that, of this law. So 5 raised to power 3 times this is what is going to give us. I think 5 raised to power 3 should give that one should give us 125 s raised to power 3. Now let's move on to number 7. A raised to power 1 over n. Anytime we have something like this, it means that this 1 over n, the value here n will always be outside there. So it gives rise to this, something like this. And the example like this, we have 27 raised to power 1 over 3. This same thing as what? Theory, what we have at the bottom here, the numerator will be inside this group root, that's 27. That is it. And this thing, you can write the final answer for it. This will give us that this is 1 over 3. It means that 3 raised to power 3, we are looking for the root, what we can raise to power to cancel this root. This one is giving us like an hint, what we can use to cancel it to get the value. So 3 times 3 raised to power 3 will give us 27 times 1 over 3. This cancel out. So finally the answer is 3. Now let's move on. A raised to power m over n. This is the extension of this thing. That means in this one we have 1. This one we have a value more than 1. So when we have something like this, don't forget that the numerator value will be outside this, and the numerator will be the power 1. So this is n root of a raised to power m. It can be like this, and it can be like this. So anyhow, so this is example 16 raised to power 3 over 4. 3 over 4. This same thing, what I apply here, that's the same thing. But let me first write it. This is 4 over 16 raised to power 3. Or this. So how do we solve this thing? The same thing, the way I solve this one. How many times can we raise? We are looking for what we can raise to the power that can cancel this 4. So we know that 4 raised to power 2 can give us 16, and we also know that 2 raised to power 4 can give us 16. So we need 4 because we need to cancel this. So 2 raised to power 4 times 3 over 4. 4 cancelled 4. So this will give us 2 raised to power 3, and this is 8. Alright, let's continue. Now a over b, that is number 9, in raised to power minus n. This is inverse. This is inverse. Anytime you have something like this inverse, the numerator will with the numerator, the position of the numerator and the position of the numerator, they will interchange their position. The value we have at the numerator will come to the numerator, and while the value we have at the numerator will come to the numerator. This is what up here, a over b will becomes what, b over n, and that minus will be removed. There is how to prove it, but there's no time. That is it. Anytime you have something like this, or you come across something like this, you just need to interchange the position of the numerator and the numerator. Thank you. So let's move on. The example here, we have 18 over 180 raised to power minus 2. So how do we do this thing? Anytime you encounter something like this, you want to remove the inverse value there, just need to interchange their value. That is 180 over 8 raised to power what, 2. And you can then move on. That's all. This is a question that they will give you, that you need to, they will ask you to simplify it. But then, you know, this value cannot be reduced. Like, you are given value outside, and you know that this value they give you cannot be, you cannot get the index value. Even if you get the index value of that number, it cannot be used to cancel, you cannot get your desired result. So you know, something like that, this is what we use. So 180, you first reduce the value. So nobody knows that, okay, 2 raised to 3, 8 is a perfect square, but 180, it is not. There is no how you can raise the power to get 180. So then in this case, that's how you reduce it. So 180 can cause each other 18, that is 1, that is 10, that is 10 over 1 raised to power 2. This will give us 10 raised to power 2, that is 100. Now let's move on to the second example. We have 8 over 27 raised to power. This is another one, inverse. What will happen to this? 27 over 8 is power 1 over 3. Now in this case, this is what I mean. Now you know this one, 180 cannot be expressed to cancel 2. You know, like to have the same power, 2 raised to power 3 difference with 2 raised to power 3, but there is nothing we can write to give us the, if there is. In some cases, you cannot find value that can cancel that, but in that case, that's how we solve question like that. So for this one, we have 27 over 8. You know that 27 can be expressed as what, 3 raised to power 3 over 2 raised to power 3 give us 8, and they have common power 1 over 3. So what do we do to this one? To factorize the power. That's 3 over 2 in the bracket 3 times 1 over 3. 3 cancel this, and this is the final answer, 3 over 2. 3 over 2, that is the final answer. Now let's move on. This is the last one on the list. I think so, because this one is very crucial, because they are very useful when it comes to indices equation. That you are given equation in terms of indices. This is very essential and is very important. Now let's move on. If a raised to power m equals to b raised to power m, then a equals to b. It's telling us that when our power are the same, then the b is also the same. And same thing goes for this one too. A raised to power m equals to a raised to power n, then m is equal to n. It's telling us that even when base, if you have base that are the same, that are equals to the same, that are equals to each other, the power too, they are also equal. This is what it's saying. And for this one too, you will maybe, I don't know, maybe you have come across something like this, that will give you a question, s raised to power 2 over 3 equals to 8, and they will say find s. In that case, you don't know how to do it. You will be looking, you know, we are fond of using, okay, when you have s raised to power 2, we usually find the square root of both sides to cancel to cancel the 2. But in this case, this is very useful. Anytime you are given value and you don't know how to, some like example I gave, s raised to power 2 over 3 equals to 8, find s. You don't have to do this. This is the law you use. That means when you have a, if a raised to power m, it could be fraction. It could be a raised to power n over m equals to n. Find that thing. Then a equals to what? You multiply two sides by the inverse of what you are given as a power here. That's how to resolve question like this. So let's move on to the examples, exercise to practice all these things, because this thing, the law is very good, but you must know how to apply it in questions. You must know how to apply it. That's very good. Now example example for this one, we have example 1. We have 2 raised power x equals to 4. Find s. In this case, how do you solve it? We have our unknown to be at the power. Now, how do we solve this question? 2 raised power x equals to 4. Find s. You are looking for the value. The value you are looking for is at the top. This is power. It's at the top. So you have base here. You have base here. You use the law. That okay, what can you use to cancel the base? Since the base, if you can make the base to be equal, then you will be able to get the power. So let's move on. Let's continue. So this with 2 raised power x equals to 2 raised to power 2 can give you 4 because you want the base to be the same, so that you get the value of x. So since base are the same, then power is also equals to power. So s is equal to 2. That's how we solve question like that. In equation, you can see it in simultaneous equation. They can use it in anything, logarithm. So you must understand that law very well and how to apply it in each of the situation. So x raised power 3 equals to 27. Find s. Something like this. Sorry. You know, we are always fond of this. Well, let's say this s raised power 3 is not s raised power 3. Let's say it is s raised power 2. You know, it's very fast and clear. You find the square root of both sides so that you can cancel 2. You know, that square root of both sides, what we are using, the value of square root is raised to power half. So what they're actually doing there is they are multiplying 2 sides by the inverse of that power. This is what I mean. Now s raised to power 3, how do we get our s here? We multiply 2 sides. Now we multiply 2 sides by the inverse of 3. You know, this is 3 over 1. So you multiply 2 sides by the inverse. Inverse, what I mean by inverse, I mean reciprocal. The value in the denominator, they will come up, and the value in the numerator will come down. So we have s raised to power 3 times 1 over 3. That is the inverse of this power. Equals to what? 27 2. We can express it as 3 raised to power 3 times inverse of that. So this will be cancelled out. This will be cancelled out. So our s will be equals to 3. That's how we solve something like this in question. So it is not actually the value of square root. What they are actually doing there is they are multiplying 2 sides by the half of that 2 or that power. So I want you to know that, to take note of it. So if a raised to power 4 equals to 81, find the value of a. For this one now, you know how to do it. Now, what do we do? Yes, that's what we are going to do. So we multiply 2 sides by the inverse of this power, that is 1 over 4, equals to 81 as well. 3 raised to power 4 can give us. Why am I using all these theory? I get it, because you must know that what you are dealing with. Okay, this is 4. You know, we want to cancel out 4, so you must look for the 81. How you'll be able to break down 81? You look for the index of 81. That it will have power of 4 to cancel out the 4 to get your value. So this one cancel each other. So a equals to what? This cancel each other. That is 3. I hope you get it. That's fine. Now let's move on. Let's do some exercises. We have this question says simplify 25 over 16 raised to power 1 raised to power minus 1 over 2. So what do we do in this one? Let me pause the video. What do we do? Yeah, exactly. This is what we are going to do. You get it. According to the law, yeah. This is what we do. This one will go up and this one come down, because we have inverse of this thing. That will be 16 over 25 raised to power what? The minus will be removed because you have removed the inverse by interchanging their position. Now they will give us 1 over 2. Now what do we do next? You look for the way how to you look for their index of 16 and 25. In the sense that they will have the same power, so you factorize it and cancel these 2 out. So let's continue. You know that in 16, 4 raised to power 2 will give us 16, and 2 raised to power 4 will give us 16. But then the best one there is what? 2 raised to power 4 raised to power 2, because we are looking for the same power. We have 2 outside, we want to cancel that 2. So that's what we are going to use. So 4 raised to power 2 over 25, 5 raised to power 2 or 1 over 2. You factorize it, this will give us 4 over 5, or raised to power what? 2 times 1 over 2. This will cancel out, and this will be our final result, 4 over 5. I hope you get it. Okay, fine, that's good. So let's move on. We have x raised power 5 over 2 times x raised power 1. This is very simple. You know that. What do we do? According to in our first lesson in summary class 01, we treat this law that multiplication returns to plus addition of the power. So let's move on. X raised power 5 over 2 plus 1. According to this law, that's still when we have x raised power a times x raised power b. This will give us what? X raised power a plus b. That's what we use there. So this will give us what? X raised power what? That is 7 over 2. You get that? So here is another trick. I think you can do this. I told you that root of this one is what? The value of root is what? Raised power 1 over 2. That is it. So when you face something like you say something like this, you don't need to stress yourself. You just need to solve it. A raised power 3 will give us what? This is a raised power 3. Division will change to what? Minus. That will be, let me first change this one. A raised power 1 over 2. So square root of a is the same thing as a raised power 1 over 2. So let's move on. You subtract this one. A raised power 3 minus 1 over 2. A raised power 3 minus 1 over 2. Then you find the LCM of this one. I think this one should give us what? 1 into 2, that is 2. That is 6 minus 1. The final answer will be what? A raised power 5 over 2. Now we are moving on. Now this is number 4. Solve the equation x raised power 2 raised to x raised power 2 over 3 equals to 64. So how do you solve this one? This is equation question. So like the law we treated last in our class today. So x raised power 2 over 3, you are looking for x, you multiply two sides by the what? The inverse of this in order to cancel out this. So inverse of this will be what? 3 over 2 equals to what? 64 raised power 3 over 2. So yeah, this one cancel out, this one cancel out. So we have x equals to what? 64. So how do we get rid of this thing? Of these two? If you want to move further, 8 raised power 2 will give us 64 times 3 over 2. This one cancel out. This one give us what? 8 raised power 3. That means 8 in 3 places. So let's move on because of our time. Number 5, solve the equation 3 raised power y equals to square root of 3 over 9. So here is another trick. I told you that when you have square root is same times what? Raised power half. Then we have what? 3 raised power y equals to what? 3 raised power 1 over 2 over 9. Now what do you do in this case? You move on by writing what? 3 raised power equals to 3 raised power 1 over 2 is the same thing. Now this 9 is what? 3 raised power 2. Because why do I use 3 raised power 2? Because we need them to be in the same base before you can apply indices law. And don't forget that this division returns to minus. So then let's move on. 3 raised power y equals to what? 3 raised power 1 over 2 minus 2. Why do I change this to minus? Because this is also division law. So you subtract this one from this, you get your answer. So let's use SCM. That is 2. 1 into that is 2. That is 2 minus 1 into 2 into that will be 1. 1 times 1, that's 1 minus 2. 1 into that is 2, that's 4. This will give us 3 raised power y equals to what? 1 minus 4, that will be minus 3. That is 3 raised power minus 3 over 2. Yeah. So how do you solve this one further? You know that since their base are the same, what do we do? Then y, their power are also the same. That's minus 3 over 2. It's very sweet and it's very simple, straightforward thing. So when you master the law and you know how to apply it, solve different question, when you practice it, you will get used to it and know it. Now this is my final takeaway. So I want you to tell me and give me the answer in the comment section. Now, what's the x? What is x times square root of x? Give me the answer in the comment section. Thank you.